virtual stuff up to today. So 3 times now, Devin has told us that if we had a parabola that looks like this, the minimum occurs at negative b over 2a. And so that's a rule. We learned that with part of the quadratic formula. So the whole quadratic formula goes negative b plus or minus square root b squared minus 4ac all over 2a. But look at it if I write it like this. It means the exact same thing here. My drawing is different. It means the exact same thing here, but this is the middle, and this is plus this amount and minus this amount. So this is the middle. And see how plus or minus means you go right or left the same amount? That's why the minimum lies at negative b over 2a. That's the middle. And then everything else happens this distance away, depending on where it is vertically. So why do we care? Because no matter what function we have, I can make up any function I want. I could say y equals 4x squared minus 16x plus 77. And as long as I recognize that it's a parabola, hey, look, it's a parabola, then I know exactly where the vertex is. And in this case, I even know that it's a minimum value. How do I know the minimum value exists? What kind of parabola is this?
It is a positive.
Positive. So this value is positive. The x squared determines the shape. And so it looks like this. And I don't even have to graph it because Devin has reminded me that if I plug in negative b, right? So negative 16 over 2 times the 4. So 16 is b and 4 is a. And then figure that out. I end up with 16 over 8 or 2. So that means that my vertex lies at 2. And then how do you find the y value? Put the x in. So we know 2. Now we go, well, what is y when we have 4 times 2 squared minus 16 times 2 plus 77? And then we do the rest of that math out. So what's that? 4 times 4, 16 minus 32 plus 77.
Wait, why did we set it up? Oh, we just plug in.
So now that we know this, then we plug it in.
Plug in for x.
And that tells us the y value. So that ends up being negative 16, so 61. So this has a minimum value. This is my shape. That means at this point, even though it looks really high up, it happens to be a minimum value. The lowest point on the parabola is 61. That's the minimum value. It happens at 2. So the main thing out of the section 3.2 was being able to tell minimum and maximum values based on whether this is positive or negative and negative b over 2a. And then I had videos that had some solutions, and you were supposed to go through those, and you were supposed to ask me questions. Many of you are going down to college next year, if not next year, the next year, and no matter what class you take, somebody's going to make you take a math class. There's going to be a lot of learning that you have to do on your own. It's going to be more like the last 2 weeks. I mean, there's going to be a person, but they hit big things, and then you have to do all the little work in the middle. So I'm going to encourage you to go see the people who have office hours to ask questions, kind of like I did virtually. I hope they'll have them in person. If you make a connection with your teachers, then they're going to know you. And if it comes to being, I wonder if they're going to bump me up from a something minus to the next grade, they might very well do it if there's a curve going on because they know you and they've seen you work hard. There's also Tutor Centers where you can just go do math homework and say, come help me, just like you would in a regular classroom. Don't miss those opportunities. And if you don't know that they happen, they do happen. You just have to find them. So ask somebody for help and they'll point you in that direction. All those resources are out there. One of my calculus students called me lots of days to do calculus homework. So I'm still here. Like, I still get emails. If you get really stuck on something, let me know. Okay. But for the most part, y'all didn't reach out to me over these last 2 weeks. So it's hard for me to know where you're stuck. And that's on you as juniors and seniors. So this was 3.2, the main point of that. Then what did you also do? You did 3.3, and the main idea there was, I can't get there, other common functions. So I gave you a worksheet, right? The sub gave you all the parent functions. So I want you to know where that is. And if you don't know where it is, find the post that is on 3.3. It's called Other Common Functions. Because I'm okay, especially given the last 2 weeks we've had where we were virtual and then I was gone for a week, I'm okay with you using that as a reference. So if you were supposed to graph something that said x minus 4 all cubed plus 7, if you're able to look at that parent function list and then translate it, then you're in a good way. So what did we do in this section? We had the parent function worksheet. And we discussed translations. Graph using translations. So let's talk about those translations in our summary that we're doing right now to catch up. So let's say we had y equals x minus 2 cubed plus 4.
This eight.
Yes.
So when you said for the top, I'm talking about the parabolas.
Uh-huh.
You said that if the first number, like the 4x squared, was positive, that means it was a positive parabola.
It's an up parabola. And if it had been negative, it would have been down. So if it said y equals negative 4x squared, it would be down. So this one would have a maximum value. Here we go. Shook the whole wall. Okay, so back to 3.3. So there's a whole bunch of functions on that worksheet. Do y'all have it? Do you know what I'm talking about? Okay. So which function is this supposed to be a variation of? X cubed. So we're going to think about, and you don't have to necessarily write down that the parent function is x cubed, but that's handy because then you go look at your chart and you go, if this is x cubed, it should look like this. And it would go through 0, 0. It doesn't actually go down there. It goes up. Here's my prettier version. You can look at your sheet and go, there it is. But mine doesn't go through, and you have to know where things shift. Mine doesn't go through 0, 0. Mine is different. So what is different about mine? Yes. So things in parentheses are opposite math. This means it goes right 2. And this means it goes, let's say this one goes up 4. So you can actually, and I should have just drawn this bigger. You can actually, and I think your homework is supposed to do this, graph the parent function, and I'm just going to do this with some dots so I can see it. But then I'm going to take this equation right here and go right to 1, 2, and then up 4, 1, 2, 3, 4, and I'm going to draw the same shape, and that's my shifted equation.
Oh, I have a question. So you're going up 4 from the 0, 0.
Yes.
And then you're going to the right 2.
So every point is moved this way, right? But it's good to have something that makes sense. Like, it's harder to move the equation from some dogleg position down here. It's much easier to pick the central, like if it was a parabola, I would move the vertex and then draw the parabola from there. If it's something like this, where it goes off in two directions, I'm going to move the body of it, and then I'm going to put the two arms on it after I move it. That's how I think of it.
Okay.
So for things that have a middle, I move the middle. For things that have a bottom, I move the bottom. That is not very mathematically speaking, but that makes sense to me. So things that are in parentheses are opposite math, parentheses. Things that are not, they move y. So this is why this was a vertical translation up 4. It moves the y value. It's like on the outside. It's like outside with y. It moves y. Things that are inside with x, we're trying to solve them. The reason it's opposite math is because we're trying to find the number that makes this 0. So what number will we put in for x that would make this parentheses 0? 2. It's actually opposite math. So that's our goal there. So with that worksheet, if you know what everything looks like and you understand the translations, you can move stuff around. So while we're here, let's do a couple more translations.
Wait, so inside parentheses is x movement and outside is y movement?
Exactly. All right, so write this down. This is our example 2. There's a lot of things we could do to graph this. We could make an XY chart. But if you have your little cheat sheet, then you know what the parent function looks like. So when I look at this, I notice where x is, and I try to look on my worksheet for the function that looks the closest to it. So what do you think is the function that's closest to this? So this is like the square root of x, and then I'm going to write some stuff down in a sec, but I'm going to write out the square root of x in my little drawing looks like this. Okay? So I have a general shape for it, but this particular example has 4 things that are different. Somebody tell me one of those things. Okay, so this. So let's do the 4. So 4 is, this affects x. X goes, so this is the x-axis. X goes left to right. This is 4 with opposite math, so it moves which way? Moves left 4. So we're going to take each change and write it down. Somebody give me a different number or a thing. Okay, so the 3 is a vertical shift. It moves up 3. So this one was opposite math. This one is same math. So pause. Don't anybody say anything until everybody's got that down, because I don't want you to get lost. Okay, there are 2 other things that are different in this problem. What else?
That -2.
Okay, and we're going to do them separately. We could do them together, but I like to think of them separately. Are they with x, or are they outside the part with x?
They're outside,
so
that affects y.
So these are both y things. Let's do the 2. 2, is it added, multiplied, divided? What is 2?
It is subtracted. Oh wait, that's multiplied.
It's actually multiplied. It has an opposite sign, but it's multiplied. So this is a vertical stretch. So it happens to do with y because it's on the outside, and y is up and down, which is vertical. And whatever number we have, we're going to multiply by 2. That makes it bigger by 2, like it stretches it out. So this is the silly putty. Multiplying by 2.
So that's opposite math?
No, it's the same.
Oh.
I haven't done the negative yet.
Oh.
Okay?
Right, okay.
So the negative I'm going to think of as separate. The negative is also on the outside. Only the things in the parentheses are inside. Everything else is outside. So this is on the outside. It has to do with y. And what does it do? It's vertical something else.
It makes it shrink?
No, shrink would be if this 2 was smaller, like a half. This is the flip that somebody said out loud.
Oh, flip.
Vertical flip. So we're going to move stuff around. Are you ready to do this?
Yeah.
Okay. So we're going to start. This is the most, all of the points move, but this is the one that makes the most sense to start with. So instead of 0, 0, we're going to move left 4, left. 1, 2, 3, 4. So I'm right here right now. And then I'm going to go up 3. 1, 2, 3. So this is my new starting point. And if that's all I had was those two things, I would draw the same shape right here. Okay? But this one is going to take this shape and stretch it, but also flip it over. So this is when I wish I had like a transparency to write on so I could move stuff around. So what does that mean? This is what it would look like if it was stretched. Everywhere that this is this high, it would be twice as high. It would be, and then right here is this high, it's going to be this high again. Like this would be stretched without moving it around. So my shape is going to be like this, except where does it go? It goes down.
Yeah.
So it actually gets stretched and it goes down. And this is just a sketch, okay? It's not, I didn't go do points and I'm not being very specific, but I have a basic idea of what this looks like because instead of having the same shape, right, it would be flipped over this way and look the same. It's actually bigger.
Mm-hmm.
So this should have a stretch. And you could plug in a point and check it.
It's just a sketch you're saying, so you don't have to be...
You don't have to be specific, but you could check something, right?
Okay.
So what if we check 0? Right? 0 should be negative something.
Mm-hmm.
Let's see if that works, right?
Mm-hmm.
So how do we do that? So if we want to check something and see if we're completely off base or whatever, we're going to check 0 for x. And so we're going to say y equals, and I'm going to rewrite this whole thing, but I'm going to put in 0 for x. So that'll be negative 2, the square root, 0 plus 4 plus 3. So what do I get?
Square root of 4 is 2.
Okay, so negative 2 times 2 plus 3.
Plus 3 is negative 1.
So negative 1. So my scale is off, but it's definitely negative. So it should have been here, I guess. But again, this was a sketch. Is it in the right direction? Yeah. So I'm all right. What if I did something else that would work out evenly? Let's say I did 5. Let's check 5.
Did you get negative 1 for that?
Uh-huh.
Oh.
So my graph is not exact. Maybe if I want you to be exact, I might give you an XY chart to check some specific things, okay? But this sketch I'm okay with because we did all the things we were supposed to do. We moved it left, up, we stretched it, and we flipped it. Let's just check 5. 5 would be negative 2 square root 5 plus 4 plus 3. So what do we get there? Negative 3. So this is going to be y equals negative 2 times 3. Square root of 9 is 3 plus 3. That's negative 6 plus 3 is negative 3. So this was negative 1, and I'm at 5, and that's negative 3. I mean, that kind of makes sense. Like, I'm doing okay.
Mm-hmm.
This is a sketch.
Like, if it was like maybe a little, if you want to know.
If this was multiple choice, would you pick the one that kind of looks like this and has a starting point there?
Yes.
Okay. So that's what I'm trying to get at. You have to see that it's flipped over and all the things that happen with it. But you could check some points pretty quickly. And could you pick the right one from multiple choice? And definitely, you know, all the ones that start somewhere else, you wouldn't pick those. It has to do these two things. These are the most obvious starting things to check as far as translations. Could you pick the right one with multiple choice? And that way it's already sketched for you. You don't have to mess it up, but could you tell? So that's what section 3.3 was about, using the cheat sheet that has all the parent functions. Could you move stuff around? And you had some practice there. Now 3.4 was new, but I'm going to remind you where we were last year and where we are now. So Marco, you had some questions. Have I caught you up?
No, I can't.
So you're okay.
Yeah.
So 3.4, let's remember what we did last year. So 3.4 was called variation and multivariable, meaning more than just x, variable functions. So last year we had one specific case. We really only worked with what's called direct variation. So last year we did direct variation. And the example that I gave you last year was something like y equals 2 times x. This example has multiplication here. And the words that went with this example were, if you got a certain amount of allowance and then your sibling got twice as much. You know, like say they're the older sibling. If you got $4, they got $8 because they had to pay. This is when you're younger. They had to pay for gas or take people on dates or go to the movies and pay for themselves or whatever it was. They got twice as much because they're the older sibling that had more things to do, I guess. Then we said no matter what you got, they got twice as much. So those of you in my class last year, do you remember doing that? So if you got $1, they got $2. If you got $4, they got $8. It had the same rate every time. And it's called the constant of variation. So it didn't matter. If you owed your mom $1, they would owe their mom $2. Okay? It was always twice as much, no matter what. And that's called a constant. That's an A. It means it's always the same, constant of variation. The difference in this section was you had a new phenomenon where, so we called this last year y equals A times x, YAX. That's what we called it last year, where A was a constant of variation. This book is a different manufacturer, and this is common in math. People will use different letters to mean things. They would have called this K times X, like K for constant, even though constant doesn't start with a K, it's a sound. So in this section, the new thing was inverse variation. All right, so inverse variation. So in the functions that you saw in your parent charts, inverse variation looks like where you divide. So instead of this being multiplication, inverse variation is the K or the constant over X. So the difference is that X is in the denominator. So the rule that you were supposed to remember when you rephrase these problems was that whenever it said inverse, you put X in the bottom. And we'll look at some problems in just a minute. And then you had another thing that said jointly variable. So maybe you had two different variables that were dependent on something. So jointly. So you've heard maybe of a joint checking account. That means two people have a checking account. Those would be the two variables. And so same word, same meaning. And so let's look at some of those examples, maybe even some of the homework problems that you had, and talk about how the words go. And I uploaded solutions for these so you could check your stuff, but you do have to be able to kind of take these and reword them so they make sense. And all these problems follow a similar thing. They give you the words, which you translate into either multiplication or division with this constant, and then you plug in some data to find K or A or whatever the constant of variation is, and then you use that for more data. Are they after? Okay. There's a siren, by the way. So anyway, let's look at an example. 3.4 still. Here's an example. I'm going to write it out in words, and then y'all are going to change it into math. Okay, so here we go. Example 1. Suppose that y varies inversely as the square of x. Suppose that y varies inversely as the square of x. So in math, what we want to do is we want to take the words and we want to put it into an equation, because following that, they tell us some other stuff. They tell us that in scenario 1, x equals 4, y equals 3, and then in the second scenario, they want to know what is y when x equals 8. So they give us the scene. This is how the numbers relate to each other. They tell us some numbers, and then we go figure out some stuff. So on the other page, I wrote, first we have the words, we need to translate them, then we're going to plug in the data, and then we're going to find some other stuff. So, is it true in this example that y equals x? Is y the same thing as x? No. So y equals would just mean equals, but varies is different than equals. It means equals k. That's that you get 2 times as much allowance or whatever. So varies is not equal to, if it said equal, you just put an equals mark and do an equation. But this says varies, so it's equal that constant. And we don't know what that is. Did they give that to us? Is it over here?
No.
No. So we're going to have to find that. So we do this literally word by word. So this says, suppose that y. So what am I going to write down first?
Y.
Y. Y. And then the next thing, the varies, Liz says to write equals k. So we're doing it word for word. Y varies means equals k. There it is, equals k. Inversely, does that mean put it in the top or the bottom? Bottom. So inversely, and whatever comes next goes in the bottom, the square of x. So they don't say x squared, they say the square of x, which sounds fancy, and we just write it as x squared. So there's our equation from the words.
Whenever they said the square of x, I always read it as the square root.
Right, yeah. They were trying to be fancy, and we're not going to let them be that fancy. We're going to make sure we understand. Now, in scenario 1, we have x and y. X and y. We don't have k. So if we plug them in, we'll get k. So we do that. We have more information here. So we use this one. We say y is 3 equals, I don't know k. I do know x, so that's going to be 16. How do I find out what k is?
You have to multiply by 16.
Multiply both sides by 16. And that's 48. 48 equals k. So we found the constant. That's like the allowance multiplier. Okay? It's the same in every scenario for this problem. It doesn't change. It's a constant variation. It stays constant. So now we do it again. We say scenario 2, we just rewrite everything again, but we don't know why. So we don't replace y, we say y. For k, we know what it is. It's 48. Oopsies. Too big a line. And then we do know x squared is 64. And look, y equals. We just have to reduce this and we're done. 16 goes into both of these. So 16 goes 3 times over 4. So y equals 3/4. So whatever scenario this is, the relationship is the same in every scenario represented by the k.
Where'd you get the 48 from?
So from this problem,
Oh, wait, never mind.
we're able to find for k.
Yep, my bad.
So in every scenario, this is what happens. We do the words, we make it a math problem, we plug in to find k, and then we do it again to find the other variable.
So you got 64 by doing 4 and 16.
So this says y equals k over x squared.
Yep.
And they told me 8. 8 was x. So 8 squared is 64. Are you good, or I can't tell?
No, I'm good.
Okay. So the words that you needed to learn this time were inversely, and joint would just mean you had more than one thing happening. So we'll probably look at some problems like that on a different day. I'm still catching you up. Okay, so then what did you do? We did this. Okay, so now we're going to 3.5. Let's see where we are. 3.5. Transformations. We just did transformations. I just helped with that a minute ago with all the flopping around. So we've already done a little bit of transforming. I did that with 3.3. 3.5 was about function transformations, and I just did some of that. So it's about you being able to tell the stuff from the problem and move it around. Horizontal, vertical shift, all of that jazz. Okay, so the one new thing I want to talk about with 3.5 is what's called symmetry. Symmetry. What do you think symmetry means? Shapes. And then what?
The same on both sides.
Same on both sides. So symmetry is about having the same thing on both sides of the axes. Okay, so not like a parabola that's anywhere being the same, but specifically we have these two, well, there's three versions of it.
Wait, isn't a parabola symmetric?
It is symmetric to its own axis of symmetry. In this case, we're talking about symmetry to either the x-axis or the y-axis. Okay, so we're being very specific. So I have 3 cases here. I'm drawing 3 axes. Obviously, they're all like x and y, but I'm going to name them different stuff. Okay, so here we go. This first one, let's pretend it looks like this.
Whoa.
This is some sort of interesting sine wave. Could you fold this on the y-axis and have the same thing on both sides?
Yes.
Okay, so this is more interesting than a parabola, but this is called symmetric to the y-axis. Because you could fold it and it would be the same. This is a function. How do we know it's a function?
Because it's, I don't know.
Because it passes the vertical line test?
Yes.
Okay. Whereas if I do the same thing sideways, I'm just going to do a parabola because that's easier. In example 2, this is symmetric, but not the same. Yeah, it's symmetric to the x-axis, symmetric to the x-axis. This one is a function or is not a function? Not a function. Right, because we could draw that vertical line test. And then the third is, what if it goes like, like that?
That's good.
Whoa.
See how the first quadrant and the third quadrant are the same? This is called rotational symmetry to the origin. Symmetric to the origin. I think of it like if I folded the piece of paper down and then again, it would match up. Like I folded it twice. Some people think of it as rotating. Either way, this is called symmetric to the origin.
So could we write that it's rotational symmetry to the origin?
Uh-huh. Yep, but it's to the origin and not to one of the axes. Now, in most cases, this has an even power. We call it also even. That's another name for it. Versus this one, which is called odd. And that one's neither, because it's not a function. Okay? And so tomorrow, we'll do some examples like this, where we plug some stuff in, and we see if it's even or odd, or y-axis, origin, symmetry. Okay? So I'll take a look at the homework right now and see if it's stuff that you can do, and then we'll catch up tomorrow. How many people are gone on Thursday?
What's Thursday?
AP Gov? Government? Yeah, just, okay. Okay.
Ms. Haight, this is very helpful.